Thank you, everybody, for joining us today as we talk about a very beautiful bird. This one on the screen right now, European roller, or the Eurasian roller. And greetings today from a sunny South Africa, a nice autumn day. And at the moment, the migrants, the swallows and swifts are gathering in large flocks as the leaves are slowly turning yellow and thinking about heading north back to the northern hemisphere to escape our winter and enjoy your summer. So we're going to be talking a little bit about insights from the desktop work that I do using citizen science and the fantastic data that many people perhaps here have contributed in one form or another. And then Jessica will talk a little bit more about the hands-on practical handling and the insights we've gained from the tracking data. So on that note, over to my co-presenter, fantastic Jessica Wilmot, to tell you a little bit about these two species.
Thanks, Alan.
Subspecies.
Excited subspecies. So yeah, thanks for having us. Excited to be able to talk about the European Roller Monitoring Project, which was established in December 2021 and strongly supported by Alan. So Alan, thank you for all your support. So South Africa is actually host to both subspecies, garrulus and seminawi. Garrulus breeding in Central, Eastern and Northern Europe, while seminawi breeds in Asia. Seminawi is said to be declining at a slower rate than garrulus, but we lack sufficient population data to confirm this. Back to you, Alan.
Thank you, Jessica. All right, so we're going to be showing you a couple of maps. This one's setting the scene. BirdLife International's fantastic new updated data zone map. And I just thought it might prelude that with, in statistics, we often say that all models are wrong, but some are useful, attributed to statistician George Box. And maps, of course, are models of distribution, and so some may be wrong, but they are also, of course, useful. In the map at the moment that we're looking at, we can see the breeding grounds of the European roller highlighted in yellow, stretching across Ukraine to Kazakhstan, and then the passage areas in green, and then the non-breeding distribution or passage areas in Africa in blue. According to the data zone, there are somewhere between 100,000 to nearly 500,000 birds. It's quite a spread in potential population sizes, but at least they are fairly convinced that the population is decreasing, and so it'll be interesting to see what we're seeing here from the southern perspective. What's interesting to note here is that for some reason India is not indicated as part of the range. But when we go over to eBird, we see a different kind of map, the abundance maps, which fantastically point out where the species is more likely to be encountered by their metric of abundance. So here we're really seeing the star area of Asia highlighted in bright red, and then lower probability or lower abundance metrics as we move westwards through Europe, Southern Europe to Spain. What's important to note here is that the eBird maps, the dark gray areas, which is a lot of that Western Africa area, that dark gray symbolizes that there's just not enough data there to do any modeling of distribution. So it doesn't actually indicate that there's absence over that area. The yellow indicates India and Sudan and northern Somalia to be important passage areas, and then the blue coming through quite strongly indicating Kenya to be an important destination, and Southern Africa perhaps marginally so. The overlay map over here is from Rafael Nussbaumer at Vogelwarte, and this really highlights why the eBird map doesn't show that distribution across Western Africa for this particular species, because there just isn't much data for that area. All right, so they have fantastic dynamic maps, worth visiting and having a look at. So to try and understand the distribution of the European roller from the African perspective, we decided to create these two maps to pool all the different data sets that we could in order to get a better understanding of where the birds may be and where their preferred staging grounds are. So the secretary bird icon over here represents the African Bird Atlas project set of projects, which includes the second Southern African Bird Atlas project, SABAP2, as well as the well-established Nigerian Bird Atlas and Kenya Bird Map. Included in these models are eBird distribution data gleaned from GBIF and iNaturalist research grade models. Here we can see that Botswana to Kruger National Park in Southern Africa and the Lowveld area, as we call it in South Africa, the Music savannas are very important destination grounds. And we're seeing marginal distribution through the Sahelian region, which I can't say if that is due to a lack of data or a problem in the model, or if we go to the Nigerian Bird Atlas project and we look at distribution of European roller there, it is a very scarce bird. So certainly it does seem as though this eastern southern African part of Africa is very important for the non-breeding season. Just to set the stage for the focus of my slides, I just want to make sure you have an understanding of the African Bird Atlas project, specifically from our perspective, the SABAP2 project, and the protocol and the data that we get from that in order to look at trends and understand how the birds are changing as they visit the country, how abundance is changing. So the African Bird Atlas project follows what is known as the Bird Map protocol, where citizen scientists visit spatial areas known as pentads, which are grid cells of 5 minutes by 5 minutes, latitude by longitude. And they spend between 2 hours and up to 5 days trying to create as complete a list as possible for that area, trying to visit all accessible habitats. There are a couple of mantras within the SABAP2 project. If in doubt, leave it out to avoid false positive records, but also to go deep and to go wide. So what do I mean by that? Well, when I say going deep, you'll see on the map over here, this is the coverage map, the number of lists that we've got for different parts of Southern Africa. So when we're saying go deep, we want to be revisiting certain pentads as frequently as possible so we can understand what are seasonal distribution patterns or also long-term patterns, longitudinal patterns of change. And that's great since the project has been running since 2007. We now have a very long data set to see how birds are doing and look at trends. We know from citizen science projects that there can be quite a challenge with regards preferential sampling bias, and the wide part of the mantra, go deep, go wide, is to try and use this map over here to target areas which are in the lighter shades of color, the whites, the grays, the light yellows, so that people going on holiday or thinking about contributing to the project can go to those areas and contribute more from those areas so that we enhance our understanding of bird ranges. Now, the way that the data is collected is great because we can use a variety of statistical models to interrogate the data. You list your birds in order of that you have seen them. We have lots of data, so we can use detection, non-detection methods, occupancy models. We can use time to detection models. But everybody's go-to favorites, statistical measure, is a very easy one to understand. It's just how frequently over a set of lists for a pentad, any set of pentads, the species has been recorded. So that's, we'll get to the moment, that's called the reporting rate, and that's our relative abundance measure. So the image that you may have been focusing on while I speak, rather than listening to me, is this one here, which is this dynamic model which we've created using reporting rates across the seasons for European roller. So we're interpolating where the birds are from month to month. This is not tracking data. This is just citizen science data. And we're getting an idea of these birds moving into the country, starting from the first birds arriving maybe September, October, and then here in full force over our high summer months, December, January, February, and then dispersing from March onwards. And then basically an empty map over our southern winter months, July, August. So the great thing about this data set is that all the records, all these lists, they are checked. So there is a vetting to make sure that we don't have false positive records creeping into the data set. So anybody who submits an unusual record has to defend that record, which can happen. We do have birds showing up in unusual places, and of course, change is also attributable to a changing world around us. And these relative indices of abundance have been cross-checked against actual population counts. And the example on the screen over here is for the Marshall eagle. I won't get into the little red hills over there. Those are just bootstrap confidence measures of different statistical things that we can do with the reporting rates and the presence absence data. And basically in that little histogram, or density plots, we've got everything in the negative section of the zone, and that's all painted in red. And generally the maps which we'll be showing on now, red is a bad thing, it shows decreases. And this paper showed that the changes, the decrease in reporting rates were correlated with declines in nesting birds within the Kalahari. So a good example of the SABAP capturing declines in the species here. But we've also got, it's not just bad news stories, it's also good news stories. One of the examples is for the African black oyster catcher, a species where a lot of conservation measures were put in place to stop declines, which were happening. So beach closures, protection of nesting sites, and the species has also benefited from an invasive mussel and has actually expanded its range in some parts of the country. So again, we can see that being reflected in this SABAP2 data. All right, so then what are we seeing for the European roller? So the first maps that I'm showing over here are comparison maps between a historic atlas project, which was done from 1987 to 1992 at a quarter-degree grid cell resolution, different from SABAP2. So you have 9 pentads which fit into 1/4-degree grid cell. So a static map on the top over there, where again red is showing areas where we've got lower measures of relative abundance for the first part of the SABAP2 period, so 2007 to 2015. And in the lower dynamic image, breaking that apart to show quarter-degree grid cells where we've got increases in blue and decreases in red, and no change in gray. And we'll see that that red is certainly standing out quite dramatically if we look at the distribution between these historic reporting periods for the species over here. So fast forward to what data we actually have within the SABAP2 dataset at the moment. The distribution, first of all, looks far more sparse compared to the first Atlas project, far fewer data points, and red certainly shining through here more than blue. So looking like even within this 2007 to 2023 period, for which I'm showing data over here, where it looks like we have declines. Now we do know from the coverage map that there are quite large areas of the potential range of the European roller which aren't covered so well by atlasing projects, very remote areas. And so what we can do is we can predict where that species was meant to be for the first period up until 2015, and then compare that to the later period up until 2023. And using these prediction models, again, we're seeing a lot of red on this map, which suggests a lower probability of reporting, especially over the arid Kalahari, Eastern Karoo regions. But a healthy swathe of grey over the Kruger National Park and northern KZN, suggesting, at least in those parts there, the population may be stable. But overall, these maps are pointing to an alarming trend for the European roller. So just some more things that we can do with the data that we're collecting. So SABAP2 participants or ABAP participants often use an app to collect the data. The preferred app is BirdLife. where we also get GPS locations, and we can then create a probability of occurrence map. So this one here now, finer scale occurrence map for European roller. Again, bright yellow here showing a higher probability of presence within that low felt region, and the lighter green area for our arid zone, the Kalahari or the Kalahari region, coming out in a lighter green. So they can be found there, but using the measure of relative abundance, we can see that your chances of encountering these birds within that arid zone savanna system are far lower than the low veld regions or the Limpopo regions of South Africa. So basically just saying that SABIP2 in conjunction with BirdLife is really a fantastic tool for monitoring, and we've got great data for so many species courtesy of these projects. So SABIP2 is hosted at the University of Cape Town. BirdLife is a privately developed app. Okay, so comparing what's happening here within South Africa compared to other parts of Africa. So I've mentioned the Kenya Bird Map project, and their coverage map is superimposed on the grid of European roller presence on the gridded map over there. So a couple of things to note here is that there's a lot of Kenya which has not been covered by this particular project, so the really remote or unsafe regions of Kenya. But the other thing to note is that even within Kenya, that the areas which are getting a lot of coverage, these red areas in the coverage map, we're not seeing a large number of European rollers there. And there's a lot of data from the Masai Mara region, but the abundance of that species is certainly not very high. Instead, the highest abundance appears to be in the Tsavo region, in the southern parts of Kenya. So again, if we look at the great work that Raphael Nussbaumer and his colleagues with the Kenya Bird Map have done, using both eBird and Kenya Bird Map projects, as they compared where the species is now compared to where it was historically distributed, according to the first Kenya Bird Atlas. And we see in that bar at the bottom that for what is more correctly known as the Eurasian roller, the number of cells from which the species has been lost is 52, which is quite dramatic. It's still found in 65 of the grid cells that they're looking at, and it's only been gained in 19 or 20 cells. So not looking good, in Kenya for this country over here. So moving on to these bar charts, what we've got again here is the measure of relative abundance, but now standardized per year. So it's a year on the x-axis from the start of the project from 2007 up until 2024. The blue bars are for our reporting rates within South Africa, and the green bars are the reporting rates in Kenya. And it's really interesting to see that there appears to be a cyclical pattern of occurrence that matches. It is correlated between those two countries, suggesting that what reaches Africa is really a function of what's happening in the breeding grounds in any one year. So when we have a low year in South Africa, it's not because the birds are staying in Kenya. It's just because there are less birds reaching South Africa or Africa, generally speaking. So that's a fascinating insight. And this bar ends in 2024, which was the lowest reporting rates for European roller in the history of the SABIP2 project. And that was confirmed by Jessica's on-the-ground fieldwork, which she'll touch on in a moment. But it's not all doom and gloom. This year reporting rates are up. So again, we're into an up, looks like an up peak in the cycle over here. So it was really interesting to try and understand why this is happening. We haven't yet done research on that, but just prior to this talk, I was looking at droughts in Kazakhstan, and I was not surprised to find a paper which did report severe droughts for 2020, 2021, which is when we saw dips of the population, the previous dips of birds reaching South Africa. All right, so on that note, I will hand over to Jessica to tell about the challenges that the rulers are facing on the ground.
Thanks, Alan. So, in developing a conservation project, it's crucial to first understand the threats affecting a species' survival. So, like many migratory birds, European rollers are encountering a range of threats throughout their life cycle, including habitat loss due to agricultural expansion, reducing prey and nesting sites, insecticide use leading to secondary poisoning and further prey decline, climate change causing droughts, extreme weather, and desertification, infrastructure collisions, whether that's on roads, power lines, or wind farms. And then the European roller is a particular species that's threatened by illegal killing and pet trade, particularly along areas on their migration routes. Next slide, please, Alex. Alan, can you go to the next slide, please? Thank you. So the Flyway Action Plan for the European roller is the core framework guiding our research. It sets out key actions needed to help reverse population decline. It also emphasizes the need for additional data to inform effective conservation interventions across the species' entire life cycle. So in addition to these conservation measures, the plan highlights critical knowledge gaps, particularly with the species non-breeding range. And these include lack of monitoring at overwintering grounds, uncertainty regarding the migration routes, and limited understanding of habitat use along migration routes and in Africa. Next slide, please, Alan. So our research objectives align to few of the high and medium priorities identified within the Flyway Action Plan and include the following: identifying migration routes from Africa, identify key stopover sites during migration, understanding habitat preferences within Africa, including how much of that is actually protected and what implication climate change is actually going to have on those habitat preferences, and then also just to continue monitoring population trends in Africa. Next slide, please, Alan. So our project encompasses two elements. We have the ground monitoring, which Alan was mentioning. It involves repeat annual transects in key areas and in different habitat types in South Africa. We use a program called BirdLife to log the data, and the protocol is actually embedded in that app, which makes it really user-friendly. So at the end of each season, Alan analyzes the information that we gather from our citizen scientists and the monitoring that I do in Kruger National Park. And we produce a monitoring report, which we share with the relevant stakeholders. And this year, Alan actually incorporated the data from Sabab 2, which really highlighted these various trends that he was referring to earlier on. That said, we are extremely reliant on citizen scientists to help us with the transect monitoring. So a big shout out to them to help us with this project. If it wasn't for their willingness, we really wouldn't be able to reach such a wide area that we are currently monitoring. So yeah, it's very useful to have such a support network. And then the ground monitoring is actually complemented by satellite tracking and color ringing. March last year, we deployed two low-tech trackers. One stopped transmitting at the Horn of Africa, which is that line in green. It was a confirmed male. The other individual, a confirmed female, traveled all the way to Uzbekistan, the line in red, where she stayed for 72 days before traveling to India, where she spent a few weeks in December, end of December 2024, so quite late in the season. She arrived back in South Africa, and that's the line in blue. Just to highlight, during her migration, she spent 27 days in Somalia, slowly making her way to the Horn of Africa before embarking on two ocean crossings. So it really just highlights, as Alan actually also mentioned, Somalia being a really important country for some of these individuals. Her spring migration took approximately 2 months, while her autumn migration took 2.5 months. And you might notice that the lines are quite straight for her return migration. And it's not because she was traveling in such straight lines, it's because we weren't receiving regular transmissions. Unfortunately, we assume her feathers have grown over the solar panel, preventing sufficient solar charge, and there's a mechanism within the tracker where it shuts down if it reaches a low voltage to conserve the battery life. So once she returned to South Africa in December, we actually haven't received a transmission since then. So we'll put out a concerted effort before end of this month to see if we can go find her. If we can't, we are just hoping that when she returns to Uzbekistan, that with the movement of the feathers and her molting, that we'll at least get some data points. Excitingly, though, we have deployed 5 additional trackers as of this weekend. So it would be great to see where those individuals go. Low Tech, they've actually added an additional solar panel, so that increases the solar capacity or the battery capacity. And we've also added a little like triangle to the tracker to essentially split the feathers if they do grow over the panel. To date, we have color ringed 20 individuals and aim to ring an additional 30 in the coming season. It's a slow process. It's not as easy as trapping them in their nest boxes. And because last season, as Alan pointed out, the reporting rates or the number of individuals that we were seeing in South Africa was extremely low. So it was just very difficult to trap any individuals. And this season, although they arrived late in December, we only saw a lot of individuals February or March, which again makes it our timeline very limited when we can do the trapping. Next slide, please, Alan. So what's next for the project? So we'll continue to raise awareness for the species as a flagship for migratory birds in South Africa. You know, it was really encouraging to see the response and the support that we received when we were first sharing the migration of those 2 individuals. I think it also helped that we picked a really good name for the one who completed her migration and returned in December. So this really just emphasizes the importance of storytelling in conservation efforts. So we'll continue with those, with the 5 additional trackers that we've deployed. We'll continue to expand the monitoring in key areas in South Africa. If capacity allows, we'll encourage the expansion outside of the country. So looking at the map on the slide, those yellow lines show the current areas where monitoring is taking place in relation to SABAP 2 records for the species. And as I said, we'll continue to ring individuals and most likely deploy more satellite trackers. It really just depends how the 5/6 that we currently have in the field, how they do and what data we are able to gather from those individuals. And then we also plan to expand our research by incorporating detailed studies on habitat use and quality, along with assessing the impacts of climate change on the timing and success of migration. In addition to publishing our findings, we'll also feed that data into the Flyway Action Plan, which is said to be updated in 2027. Next slide, Alan. And then just to end off, yeah, we are very reliant on the support that we receive, and we're very lucky that with Alan's work and with mine, we have a very strong network of supporters ranging from the RSVB and the Ecological Restoration Fund to the various organizations that are helping, organizations as well as reserves in South Africa who are helping us with the monitoring. And I'm sure Alan would also just like to chip in and thank all the sponsors.
Thanks, Jessica. Yes, indeed. First and foremost, this work wouldn't be possible without the citizen scientists. So anyone who's contributed a full protocol card to the African Bird Atlas projects, thank you very much. Please keep it up so that we can better understand what's happening with the species going into the future. And yes, various sponsors support the work at BirdLife South Africa and the Science and Innovation Program. Thank you very much to them as well. And thank you everyone for tuning in today and listening. Look forward to hearing your questions.